4 months of total darkness, temperatures that can plunge to nearly 40 below, ground that is frozen solid. And yet, if you warm it even slightly, it turns to mud and swallows whatever you built on top of it. And somewhere in the middle of all of that, someone decided to build a runway. Welcome back to the channel. Today, we are looking at one of the most extreme feats of civil aviation engineering ever attempted in the history of modern infrastructure. We are talking about Svalbard Airport, Longyear, a working commercial airport, serving real passengers with real jets, operating year-round, sitting on a landscape that by every logical measure should make it impossible. This is not just an airport in a cold place. It is a precision engineering system planted in continuous permafrost, roughly 1,300 kilometers from the North Pole, accessible by no road on Earth, surrounded by polar bears, buried under polar night for months at a stretch, and kept alive entirely by the will of the engineers and workers who refused to accept what the Arctic was telling them, that this place was not meant for this. Imagine that every single piece of concrete, every steel bolt, every length of pipe, every instrument panel, every sack of gravel, and every roll of insulation had to travel by sea from mainland Norway, across one of the most volatile stretches of ocean in the Northern Hemisphere, before a single day of construction could begin. And that if the supply ship was delayed, the work stopped. And that if the weather turned, as it always does in the Arctic, the work stopped again. And that even after the structure was finished, the ground beneath it was always working to undo it. Before we continue, make sure you subscribe to the channel. We cover the engineering stories that most people never hear. And stay with us until the very end of this video, because what the builders discovered beneath the surface of this project is something that will change the way you think about the ground you walk on every single day. At first, there was only this, a valley on the western coast of Spitsbergen, the largest island in the Svalbard archipelago, hemmed in by mountains and open to the Arctic Ocean. No terminal building, no lighting system, no fuel depot, no fire station, no navigation beacon, no de-icing infrastructure, no control tower, just tundra, rock, frozen ground, and the wind. A wind that here does not simply blow, but pushes with the full, indifferent weight of the Arctic itself. The community of Longyear sits near this valley, a settlement of roughly 2,000 to 2,500 people that by every geographic measure has no business existing. There are no roads connecting it to any other place. There is a small harbor, but in winter, sea ice can make it treacherous or impassable for extended periods. The only reliable, year-round thread connecting this community to the rest of the world is the airport. Without it, Longyear does not receive its food, its medicine, its spare parts, its emergency medical evacuations, its researchers, its tourists, or its fuel. Without the airport, Longyear does not survive. So the stakes were never abstract. They were immediate and human. But here is the problem. And it is a problem so fundamental that it shapes every single decision made on this project. The ground at Svalbard is not ordinary ground. It is permafrost. Permanently frozen ground that in places runs hundreds of meters deep. And permafrost, as any Arctic engineer will tell you, is a material that demands absolute respect, because it behaves in ways that completely reverse everything you learned about construction in temperate climates. In a normal environment, you warm the ground to work it. You compact it, you stabilize it, you pour your foundation into it. The warmth does not hurt the earth. But in permafrost, warmth is destruction. If you pour a heated building directly onto frozen ground, even gently, even slowly, the heat from the building seeps down into the soil. The ice crystals that give permafrost its load-bearing strength begin to melt. The ground stops being solid and starts being slurry. And whatever you built on top of it, a wall, a runway, an entire terminal building, begins to tilt, crack, sink, and eventually collapse. This process has a name, thermokarst subsidence, and it has destroyed structures across the Arctic that were built by people who underestimated it. So if you build directly on the permafrost, the structure destroys its own foundation. And if you try to remove the permafrost and replace it with something else, You are attempting to excavate hundreds of meters of frozen ground across an entire airport footprint in one of the most remote places on the planet. The logistics alone are unthinkable. The cost would be incomprehensible, and you still have no guarantee that the permafrost beneath your replacement material will not shift. So the solution was not simple. It was a system, a layered, interconnected, constantly managed system that does not fight the permafrost but works with it. That does not try to remove the ice from the ground, but instead protects it, preserves it, keeps it cold on purpose, and builds the airport on top of it, as if balancing a tray on a perfectly maintained column of frozen earth. Then came the beginning. And the beginning was not the concrete. It was the survey. Before a single truck moved soil and before a single pile was driven into the ground, teams of geotechnical engineers had to map the subsurface of the entire site in extraordinary detail. This is not a simple process in any environment. In the Arctic, it is made exponentially harder by the conditions. Every borehole drilled into the permafrost to collect soil samples was a race against temperature change. Because the moment you drill into frozen ground and expose it to the warmer air above, you begin the very process of melting you are trying to prevent. Samples had to be extracted quickly, carefully, and kept frozen throughout the analysis process. The engineers needed to know not just what the ground was made of, but how much ice it contained at every depth, how that ratio changed across the site, which layers were most vulnerable to deformation under load, and where the natural drainage channels ran. Because in an Arctic landscape, water management is not just a convenience, it is a structural imperative. Every drilling site mattered. Every soil core mattered. Every temperature measurement mattered. The data gathered in this phase would determine where the runway could safely go, how deep the piles would need to be driven, and what margin of safety would be built into every structure above. Then came the challenge of getting everything there. There are no roads to Svalbard from the Norwegian mainland. There is no rail line, no pipeline for construction materials, no convenient supply network. Everything, and this word must be understood in its absolute sense, everything had to arrive by ship from mainland Norway. Steel, cement, aggregate, fuel for the construction machines themselves, spare parts for those machines, food for the workers, medical supplies for the workers, safety equipment, instrumentation, electronics, insulation materials, every cable, every junction box, every meter of conduit, every light fitting, every fire suppression component, every length of rebar. All of it, loaded onto cargo vessels, sent across the Norwegian Sea, and offloaded at Longyear's small harbor during the navigable season. The construction window at Svalbard is brutally short. The harbor is most accessible in summer. The ground, even at its most workable, is unforgiving. Blizzards can arrive with almost no warning and shut down outdoor work entirely. The light conditions during polar night make precision outdoor work in winter not just difficult, but actively dangerous. This means that a substantial portion of all material deliveries had to be timed with extraordinary precision, arriving in summer, stockpiled on site, and then used throughout the year's work cycle in the sequence and quantities planned months in advance. If you over-ordered something, you had wasted ship capacity that someone else desperately needed. If you under-ordered something, you were not simply going to a hardware store. You were waiting weeks or months for the next supply vessel. This was not logistics. This was choreography. And every calculation had to be right. Then came the foundations. The decision to build on permafrost rather than try to remove it meant that the foundation strategy had to be inverted from anything done in conventional construction. In a temperate climate, you excavate down to stable bedrock or dense soil, pour a concrete pad, and build up. Here, the target was not to excavate down, but to protect downward, to ensure that no thermal energy from the structures above ever reached the frozen ground below in quantities that could cause damage. The primary foundation method was driven piles, long steel columns, hammered or drilled deep into the permafrost until they reached layers of sufficient bearing capacity. These piles were not bolted to the surface, they were frozen into the permafrost itself. The ice surrounding the pile, when kept cold, grips the steel with extraordinary force, a bond stronger in many conditions than conventional concrete anchorage. But this bond only exists as long as the surrounding permafrost stays frozen. The piles are the airport's skeleton. The frozen ground is the airport's muscle. Destroy the ice, and the skeleton collapses. To preserve that ice, the structures above the piles were elevated, deliberately raised off the ground on the pile caps, leaving an air gap between the base of the building and the tundra surface. This gap is not incidental. It is engineered. Cold Arctic air circulates continuously through that gap, removing any heat that might otherwise conduct downward from the warm interior of the building into the permafrost below. The building hovers. The ground beneath it stays frozen. The bond between pile and permafrost stays intact. Then came the runway. And this is where the scale of the problem becomes visceral. A runway is not a building. It is a long, flat, continuous surface subject to concentrated loads from aircraft weighing dozens of tons, landing at speed, braking hard, day after day, year after year. It cannot have piles in the same way a building can. Its entire surface must be uniformly stable, and yet it must sit on top of permafrost. The solution was a carefully engineered aggregate base, layers of carefully graded rock and gravel, built up to a design depth that acts as a thermal buffer between the warm asphalt surface and the frozen ground below. The thickness of this base, the specific grading of the materials used, the drainage channels cut to prevent water accumulation, the gradient of the runway surface itself, all of it was calculated to keep the permafrost beneath exactly as cold as nature made it, even as aircraft worth tens of millions of euros roll across it every single day. But the runway alone is only one part of what had to be built. Consider everything else an airport requires to function. A terminal building capable of handling passengers in subarctic conditions, insulated not just against cold, but against the moisture-laden Arctic air that can cause catastrophic condensation inside structural walls if the thermal gradient is not managed correctly. A control tower with communication systems designed to operate in electromagnetic conditions shaped by extreme latitude, where standard radio propagation behaves differently, where GPS signals can be affected by geomagnetic activity, where instrument landing systems must function in the near-total darkness of polar night. A fuel storage and distribution system that must handle jet fuel at temperatures where viscosity changes become operationally significant. A de-icing and anti-icing operation capable of keeping aircraft surfaces clear not just of ice, but of the particular combination of wet snow and freezing rain that Svalbard's maritime Arctic climate produces. A fire and rescue service stationed and equipped for a runway that, in the event of an incident, is not backed by mutual aid from any nearby facility. The nearest alternative airport is hours away by air. A power generation and backup system, because in a place where the grid is local and the weather is extreme, power failures are not theoretical. An instrument landing system and approach lighting for an airport that operates through 4 months of continuous polar night. Navigational aids, weather monitoring stations, maintenance facilities for the airport infrastructure itself. Every system mattered. Every backup mattered. Every redundancy mattered. Because there is no calling for help when help is 1,300 kilometers from the North Pole. Then came the matter of polar bears. This is not a metaphor. Svalbard is home to an estimated 3,000 polar bears, a population that exceeds the human population of the archipelago. Polar bears are apex predators that can move with speed and silence that humans consistently underestimate. Any outdoor work on the airport perimeter, any inspection of runway lighting at night, any maintenance crew working in low visibility conditions required protocols for polar bear encounters. Workers moving outside in certain conditions carried safety equipment. Scouts monitored the surroundings during outdoor operations. The wildlife of the Arctic is not a backdrop to this story. It is a participant in it. Then came operations. And operations at Svalbard Airport is a discipline unto itself. The approach into Longyear requires navigating between mountains in an environment where weather changes can happen faster than a standard instrument approach procedure is designed to accommodate. Winds can shift in direction and intensity within minutes. The surface wind at the runway threshold and the wind at approach altitude can be entirely different in speed and direction due to the mountain terrain funneling and accelerating airflow in ways that do not exist at flatland airports. Pilots operating into Svalbard require specific training and qualification. The airport operates special procedures. And through all of it, the darkness, the storms, the technical complexity, the airport keeps the community alive. Most passengers who land at Svalbard Airport, Longyear, look out the window and see a runway, a terminal, mountains, and perhaps the pale blue light of Arctic winter. They do not see the kilometers of driven steel piles holding the structures above a frozen ground that was never asked permission to be built upon. They do not see the engineered air gaps beneath every building, cold corridors that have no purpose except to keep the ice below from waking up. They do not see the drainage systems running beneath the aggregate base of the runway, channeling away the meltwater that summer creates before it can pool, refreeze in the wrong places, and crack the asphalt from below. They do not see the instrumentation embedded at depth in the permafrost, monitoring ground temperature in real time, sending data to engineers who watch for the first signs that the thermal balance the airport depends on is shifting. They do not see the supply chains, the ships that cross the Norwegian Sea season after season with everything the airport needs to continue existing. They do not see the decades of decisions, calculations, failures, corrections, and hard-won knowledge that went into building something the landscape never offered any encouragement to build. They land. They retrieve their bags. They walk out into air that is close to 40 below, or into summer sunlight that has not set in weeks. And the airport is simply there, as if it always was, as if it was easy, as if the ground beneath it is not, at this moment, being held frozen by the deliberate engineering genius of people who understood that here, the difference between warm and cold is the difference between standing and collapse. This is what engineering at the edge of the world looks like. Not just solving problems, but keeping them solved. Not just building a structure, but maintaining a permanent negotiation with the earth beneath it. Not just serving a community, but being, quite literally, the reason that community continues to exist. Without it, Longyear is unreachable. With it, one of the most remote communities on the surface of the earth has a lifeline to the world. Every single day, through every kind of darkness. If you enjoyed this story, subscribe to the channel. We find the engineering hidden inside the structures you walk past and never think about. Leave a comment below. What is the most extreme place you have ever landed at an airport? And we will see you in the next one. Thank you for watching.